This is the video for the Hanoi Tower Routine. The routine starts here on the left, ends up over here on the right. Starts out by setting the value of stop to NG. Then it sets the value of V to active list at IG offset. Well, in the beginning, IG is set to 0, and there's only one value in active list, and that's the value for the possibility that all four numbers are in column A. That's the 1, 2, 3, and the 4 are in column A. This value, that is a possibility, is created by, if it's a 1, there's a 1. If it's a 2, it's a 2. If it's a 3, it's 4. And if it's a 4, it has a value of 8. That's the binary representation for each of the numbers 1, 2, 3, and 4. A multiplier for it being in column A is 256. If all four of them are in column A, you add them up, that would be 15. It would be the 1, the 2, the 4, and the 8 add up to 15. You then multiply the 15 by 256. That's the multiplier for column A. Same thing happens though for column B, except you add them up and multiply it by 16. And then for column A, you add them up and multiply it just by 1. So when you do that, there's a unique possibility number for every one of the possibilities of where the 1, 2, 3, and 4 are. So at the beginning, the only value in active list is 3,840, indicating they all four are in column A. Well, the next part here says that if the value of possibility is V, tell me what the value 0 to 15 is for column A, and column B, and column C. So then it knows what values are in those three columns. But it only really wants to know for now what the top value is. So given that value, which would be a 0 to 15, what is the top value in A, and put it in register A. Top value for B, put it in B. Top value for C, put it in C. Because when we make our changes down here, we only need to be concerned with what the top value in each one of the columns is. We don't need to know what the other values are. Well, now we're going to start through the changes. It says, if A is less than 1, go to BE. That's down here. Well, there are two changes that can be made. A could go to B, or A could go to C, and that's what we're going to see now. So the next thing it says, well, if B is equal to 0, meaning there's nothing in column B, well then we can go down here and make a change. It's possible. But if there is a value in B, and RA is greater than that, well, we can't make a change then. So then we go down to BC. Alright, if that is true though, then we can come down here and say, set U to V, and then we're going to subtract out the combination value for A out of it. Remember, that's the possibility number here. We're going to subtract out the part of it that's for A. And then we add to A value to the B offset to U. So now this value is the value of the possibility of that change. Next we say, is the predecessor at that offset U greater than 0? That means it found a predecessor before. we don't need to do it then. In other words, all the predecessor values at the beginning were set to 0. If it has a predecessor value, it means it's already been found. And in the beginning, the only one that had a predecessor value is 3,840, and it said it was the beginning. All right? Well, if it didn't find it before, it says, well, then the predecessor for possibility U is V, this one that we're working on. That will be the predecessor for it. And then we set an active list at offset NG. That will be the next available offset for it. We put U into it, and then we add 1 to NG. So now we have another value in the active list, another possibility that we have to pursue. It might not be in the solution, but we have to pursue all possibilities. Well, next we come down here to say C. Can we put A on top of C? Well, if C is equal to 0, well, we sure can, so it goes down here right away. Otherwise, well, if C has a value, if A is greater than that, well, we can't do it then. We go down here to BE. Well, now we're going to do the same thing as above, but we're going to do it for the value in C. We set our U to V. That's our starting point, but then we subtract our value for A out of the A column values, and we put it into the C column values. Then we check again, does this one have a predecessor already? Well, if it does, we go down to BE and we don't add anything to the active list. Otherwise, we set the predecessor for this possibility to be V possibility. And we set active list at NG to U, and then we up the value of NG. So this, it could be, see, that the possibility could be true for both of these, and we've added 2 new possibilities to the active list. Well, now I could go through all this for B, but I didn't have enough room for the entire program, so I couldn't do that. But we'll now go to C. If the value in C is less than 1, that means it's 0, go to BM down here. That means C doesn't have anything on it, so it can't be moved to A and B. But if it does have a value, and the value at A is 0, that means there's nothing on A. Well, of course it can be moved to A then, so it comes down here to BJ. But if there is something on A, well, if C is greater than that, no, it can't be done. It comes down here to BK. Otherwise, we say it can be done, so we set our U to the V. That's the possibility we're at, and we have to change that possibility by subtracting C off of it and adding the C value to A. Then we check to see if it had a predecessor before, and if it did, we can't create a new active list value because we've had the possibility on the active list before. And then we build it. We set the one at U to the predecessor is V. We put this possibility on our active list of ones to continue on with. Up that add 1 to the offset of NG so another one can be put on the active list. Well, okay, you know what's going on here. The same thing as before. It checks to see if there's nothing on B. Of course, we can move it, and you know the whole idea here. Well, eventually it gets down here to BM, and it adds 1 to IG. Well, that means it's going to point up here to the next one in active list. It's going to keep going around here until some conditions are met not to keep going around. And the next one, it says, if IG becomes greater than NG, well, it's over. Go say it's over. Also, then it also says, if NG is greater than 1,000, also it's all over. Go someplace, it's over. Well, it's only going to go to 70. So the idea that, well, we'd allow it to keep doing this until it got to 1,000, that's never going to happen. The next one says, if the value at predecessor 15 is greater than 0, meaning it's found a predecessor for 15, it's also over, because a value of 15 means that column C has the 1, the 2, and the 3, and the 4. So that would be the end of the game. We then use the predecessor that it has to go to the previous possibility, which predecessor points to the previous possibility before that, until finally we get back to the predecessor 3,840, which means we're back to the beginning. Well, this is the end of the video on the Hanoi Tower Routine.